So it's a rectangular waveguide. It's a two-port network, right? So the port 1 and port 2, the wave can travel in the hollowed location. So this is a rectangular waveguide, right? And the second one, and this is called as an isolator. In isolator have a two-port network. In isolator also have a two-port network, but it indicates the direction. What is the meaning of this? The wave can travel only this direction. Wave cannot travel the opposite direction. So it is a port 1. You can consider it's a port 2 means port 1 to port 2, but it cannot travel to port 2 to port 1. It's a two-port network. And this is the circulator. It's a three-port network. Port 1, port 2. Again, it's a port 3. And wave can travel through port 1 to port 2, and port 3 may be we have connected with some match terminations. So measuring 1, 2 and third port is we are connected with match termination. It's a circulator. So it's a clockwise circulator. Similarly for anti-clockwise circulator is available. Okay. And this is called a direction coupler. A direction coupler is a 4-port network. So here normal direction coupler shows only for a 3-port. A port 1, port 2, port 3. Again here there is a port 4, but the port 4 is terminated with the matched termination here, right? So for example, it is a port 1 with the wave, port 2 through port, and it is a coupled port. And so this is called horn antenna. So this is antenna type, horn antenna. And another antenna is called as a dielectric antenna. And second two-part is, so this is the one, it's called matched termination. What is the meaning is, the impedance of waveguides and these terminations are equal. So it's a matched termination. And next one is, and this is called as a short, movable short waveguide. That is, what is means short load. Short load means your ZL equal to 0 means, and this is called as short load. And what the difference means? Your ZL and Z0 are equal in matched termination. Your ZL is 0 in the short load. And so this is also called 4-port network, a magic T. Okay. So here port 1, port 2, and this is called sum port, and this is called difference port. And this is also called as H plane, and it is called as E plane. If you give the signal, it both same amplitude signal. So it is a sum of the ports, it's a difference of the port. Normally this port, so port 1, port 2, port 3, port 4. Port 3 and port 4 are isolated ports. So if you give the signal in one port, I am not giving any signal, so the difference comes here and sum comes here. If you give the signal from here, the two signals are comes port 1 and port 2, there is no signals comes out of the port 3. So it's called E plane, perpendicular to earth. It's a parallel to earth is called H plane. And this is called a crystal detector. So inside there is a crystal is available here. And what is the use of this? Microwave is converted into a smaller frequency. Here we are connected the probe. So probe is we are connected here. And this probe is connected to the CR. And fourth one is called a slide screw tuner. So this so here we are connected. It's a movable. And here we are connected. What is it means? We are calculating the reflector signal. And by using this one, we calculate the VSWR, standing waves. The S11, S22 values we are calculated here. So we are moving this one, and standing waves minimum value we are calculating by using this movable one. And fourth one is called a frequency meter. So it is there is a two frequency meter. One is direct and indirect, but we are using the indirect frequency meter. An indirect frequency meter I will explain in the circuit. So this is called as the indirect frequency meter. Maybe I will explain in the circuit about the indirect frequency meter.